Okay, number 67. I have to admit, I looked at this for a second, and I said, I wonder how we can do this. Are we supposed to use some kind of trig identity, or what are we supposed to do in looking at this for a minute? And then I said, oh wait, these look very familiar to the theorem 1.9 that occurs on page 65 in my book of sine of x over x and 1 minus cosine of x over x, right? The limit is the same. All the same kind of elements are there. We have the sine of x here, we have a 1 minus cosine of x here, and we have an x squared here. It's just written a little bit differently, right? So I know that I can rewrite x squared as x times x, right? So I can rewrite this as limit as x goes to 0, sine of x over x multiplied by, and kind of separate and segregate the factors of the denominator and the factors of the numerator and look at them separately. And I say, hey, these are my two special trig limits that we proved in theorem 1.9. So we know that the limit of, if the limit exists of two separate functions, right, then we can multiply what their limits are together separately, right? So I know that the limit as x goes to 0, sine of x over x, hey, that goes to 1. And the limit of 1 minus cosine of x over x exists, and as x goes to 0, it goes to 0. So the limit of these two things separately is just their limits, the limit of these two things multiplied together is just their limits multiplied together themselves. So 1 times 0 is just 0. So number 67 is done. How about number 75? Number 75, I didn't talk about it enough in class, and I think that on Monday I will come back to this a little bit, because this has something to do with something called change of variable. They go into it a little bit on page, let's see, example number 10 in the book, page number 66, where they do a change of variables, right? So it says, now by letting y equal 4x and observing that as x goes to 0, only if y goes to 0, you can write, etc., etc., etc. What that is doing is saying, hey, I have something that very much so looks a little bit like sine of x over x. But it isn't exactly. It's sine of 3t over 2t. So instead of saying sine of x over x, instead of saying sine of x over x, it's really sine of, one moment. Okay, so we don't necessarily need to use x. We could use another symbol. It wouldn't matter what that symbol was. We could, instead of sine of x over x, we could use sine of u over u, or sine of y over y, or sine of any other variable over any other variable. And just as long as these two quantities were the same, whatever it was, it could be a squared plus b squared, quantity sine of a squared plus b squared over a squared plus b squared. As long as the quantity itself was the same inside the sign and inside the denominator, then we would know that if that quantity went to 0, then this would go to 1. So what we need to do is have a 3t somewhere on the bottom, or at least do a rewriting of what 3t is. So let's say that sine of this, let's just call this one quantity, and we'll call that quantity u. So u is equal to 3t. This means that t is equal to u over 3. And we can look at what happens as t goes to 0. As t goes to 0, 3t goes to 0, so therefore u also has to go to 0. So looking at this, we can do some substitutions. We can say, all right, we'll replace 3t with u, And remember, u is just an arbitrary symbol. We're just saying, hey, I'm recognizing 3t as one whole quantity. I'm calling that quantity u. And then my t here, right, in terms of this new variable u, is u over 3. So I replace t with u over 3. And finding the limit as t goes to 0 is the same as finding the limit as u goes to 0. I'm going to cover change of basis a little bit more one-on-one when I see you in classes again on Monday. If someone could remind me, I would appreciate that, but I should remember. So now, using this new form, this new limit, because these two limits should be equal to one another, we can change things around a little bit to get it to look the way that we want, right? So here I have, in the denominator, I have 2 times u over 3. So I can bring that 3 out and put it over the 2 instead, right? Because I have 2 is the same thing as 2 over 1. So I can say, all right, well, 2 over 2 times u over 1 times 3 is the same thing as these fractions. But I can just kind of exchange, since there isn't any additive terms here, right? I can kind of move this 3 over into this other fraction. So I have division by this fraction right here, which is the same thing as multiplication by that reciprocal, right? So if I have sine of u over 2/3, I can multiply by the reciprocal of 2/3, which is just 3 over 2, and I can bring that scalar out, that scalar factor out of the limit. So that's the same thing as multiplying by 3 over 2. Limit as u goes to 0, sine of u over u. And now this is something that we know, and we can use that. So limit as u goes to 0, sine of u over u, this goes to 1. So I'm only left with, right, and that's actually what I say right here, this whole thing goes to 1, and I'm only left with 3 over 2 times 1, which is just 3 over 2. And that's the answer to number 75. We'll go over it a little bit more in class. You can also look at example number 10 on page 66 for a further illustration.